If you've ever watched top-level men's singles badminton, I mean, really watched it, it looks like absolute controlled chaos, right?
Oh, absolutely. It's all explosive lunges, these incredibly fast accelerations, brutal changes of direction.
Yeah, the rallies are so short, super intense, and then boom, right back into another one.
Exactly. And for analysts, the question has always been kind of, well, who wins? Is it the player covering the most ground or the one who's maybe more economical with their movement?
That's the core paradox we're digging into today, using some really cutting-edge sports science. Okay, let's unpack this.
Hmm.
Our mission here is to look closely at a study that used wearable tech, these little sensors, to figure out precisely how winning players move differently from losers.
And crucially, how that changes depending on the score. Is it a close match or is someone running away with it?
Exactly. So the source we're diving into is titled, Using Inertial Measurement Units to Quantify External Load in Men's Singles Badminton Matches. Insights from Set Outcomes and Score Gaps.
Quite a mouthful, but really important work.
It really is, published just this year, 2025, in the Journal of Sports Science and Medicine.
And the research team, led by Zhenxiang and Leyi Jiang, included folks from major sports universities like Beijing Sport University and Shanghai University Sport. A solid team.
Definitely. So let's start with the basics. What exactly are they measuring when they talk about external load?
Right, so external load isn't just distance run. It's the total physical work, the mechanical stress put on the athlete's body.
Okay.
Think measurable outputs, distance covered, yes, but also accelerations, decelerations, and especially those changes of direction, the CODs. That's key in badminton.
And why is badminton so unique here? I mean, compared to tennis, for instance. Both racket sports.
Very different physical demands, actually. Tennis has larger courts, longer rallies often, so it leans more towards sustained effort, maybe more total distance.
Right.
Badminton, though, it's all about these short, sharp, incredibly high-intensity bursts. You go from almost standing still to an all-out lunge or jump smash in a split second.
Much smaller court, but way more explosive, you're saying.
Exactly. More intermittent, more explosive. It's incredibly taxing in a different way. So you need tech that captures those specific kinds of efforts.
So how did they capture that? What was the tech involved, those little bumps you see on players' backs?
Precisely. They use Catapult Vector S7 units. These are tiny wearable sensors, inertial measurement units, or IMUs,
IMUs, got it.
placed right on the upper back, between the shoulder blades, near the C7-T1 vertebrae. And they record data incredibly fast, 100 times per second.
Wow, 100 hertz. That's fast enough to catch those tiny movements.
Absolutely critical for capturing those split-second accelerations or pivots. And from that data, they pull out key metrics.
Like what?
The main one is player load. It's derived from the accelerometer data forward, back, side to side, up, down, and it gives you a single number in arbitrary units or,
So like an overall effort score.
basically, yeah.
Yeah.
Good proxy for the total mechanical work done. They also track distance covered, naturally, and something they call explosive efforts. That's basically adding up all the really high-intensity accelerations, decelerations, and those changes of direction.
I like that they focus on explosive, not just every little shuffle, but the hard stuff.
Right. And they had a strict definition for a change of direction, a COD. It had to be an abrupt turn, more than 45 degrees.
And super fast, right. Less than 0.2 seconds. Like
Mhm.
blink and you miss it fast.
Exactly. So only counting the really sharp, demanding pivots.
And the study setup sounds pretty robust. Lots of players, lots of matches.
Yeah, 18 highly trained guys, national level, they class them as Tier 3, and data from 110 sets. That's a good data set.
Absolutely.
But the really clever part, I think, was how they sliced the data, not just winner versus loser.
Right, they added the score context.
Exactly. They looked at the score gap within each set. Was it close, like 0.5 points difference? Moderate, 6-10 points. Or a large gap, more than 10 points.
Okay, that context feels crucial. So let's get to the findings. What's the big picture rule? Does efficiency win out overall?
Well, when you average everything out across all sets.
Yes. The initial hypothesis held up.
Here's where it gets really interesting.
Yeah, generally speaking, the winners showed a lower overall external load compared to the losers.
So winners are, on average, working smarter, maybe not harder, less physical output.
That's what the numbers suggest. They used a stat called estimated differences, or EDs, to quantify it. Winners had a significantly lower player load. The ED was about -14 EU.
Okay, lower overall stress.
They covered less ground, too, about 135 meters less per set on average, and performed fewer demanding movements.
How many fewer?
Around 20 fewer explosive efforts and about 21 fewer total changes of direction per set.
That's quite a bit less work per set. It sounds like better tactics, better anticipation, maybe?
That's the likely interpretation, yeah. Superior tactical skill, anticipating the opponent, placing shots precisely. It forces the opponent into doing the hard running, the desperate lunges.
So the winner controls the physical cost of the rally?
Seems like it. They conserve their own energy by making the other player scramble. Interesting. And did everything show a difference? Were there movements that didn't change between winners and losers?
Good point. Yes, some things were consistent, like forward and backward movements, the number of decelerations, and even total jump counts, think jump smashes.
Oh.
No significant difference there, which suggests those are just, well, the basic physical requirements of playing badminton at that level.
Yeah.
Everyone has to do them.
Right, table stakes. The winning edge comes from minimizing those other more costly lateral and explosive movements.
Exactly. It's about efficiency in those specific areas.
Okay, but you mentioned the score gap analysis. That overall efficiency rule, it doesn't tell the whole story, does it?
Not at all. This is where the study gets really insightful, maybe even counterintuitive.
Yeah.
That interaction effect with the score gap is key.
So does that efficiency model hold up when the match is really tight, neck and neck?
No. And this is fascinating. In those really close sets, the ones decided by 0 to 5 points, like a 21-19 nail-biter, the pattern completely flipped. Winners in those close sets actually showed significantly higher intensity than the losers.
Whoa, okay. So when it's evenly matched, the winner is the one who can dig deeper physically.
Precisely. Forget efficiency for a moment. In those close sets, winners performed over 20% more explosive efforts.
20%.
And almost 20% more total changes of direction compared to the losers in those same tight sets.
So it's like, when skills are level, the ability to just physically outwork the opponent in those critical moments is what makes the difference.
That's what the data points to. It's like finding another gear. The winner manages to escalate their physical output, their mobility and intensity, right when it matters most to clinch the set. A strategic burst.
Okay, that makes sense. Then what happens when the gap widens, if someone starts to pull away?
Then the pattern flips back to efficiency. In the moderate gaps, 6-10 points, and especially the large gaps, over 10 points.
Yeah.
Winners consistently showed lower external load, fewer explosive efforts, fewer CODs than the players they were beating comfortably.
So efficiency returns when you're dominating.
Exactly. In those blowout sets, the winner's efficiency is clear. Lower player load, less distance covered. And interestingly, in the 10-point gaps, significantly fewer right-side CODs, specifically for the winners.
Okay, let's pause on that. The left versus right CO difference. The study mentioned an overall imbalance there, right?
It did. Looking at the raw averages across all players, there were way more left-side CODs, about 46%, compared to only around 16 or 17 right-side CODs.
Why such a big difference? That's almost 3 times as many on the left.
The authors suggest it's tactical. Most players are right-handed, so opponents will often target the backhand side.
Which is usually the player's left side.
Right. So retrieving those shots forces repeated, often deep, lunges or pivots to the left. That racks up the left side CO count.
Okay. So fewer right side CODs for winners in dominant sets might mean they're controlling the rallies better, not getting pushed to their forehand corner as much defensively.
That could be part of it, yeah. Better court positioning, maybe forcing weaker returns. They don't have to chase as hard. It points to that overall control and efficiency when they're ahead.
So the big picture is, be efficient, conserve energy until you're in a dogfight. Then you need the capacity to just explode and outmove your opponent.
That seems to be the winning formula suggested by this data. It's strategic energy expenditure.
So what does this all mean for players and coaches listening? This is great data, but how do you actually use it? How do you train for this?
Right, the practical application. The study gives some pretty specific recommendations based on these findings.
Good.
First, just replicating the sheer volume of movement. They found players average about 62 changes of direction per set. So coaches should build drills, like multi-shuttle feeding, that require players to hit maybe 50 or 60 CTs within a single training session drill, just to get used to that volume and maintain quality of movement.
Okay, building the base capacity. But what about training for those close sets? That ability to ramp up intensity?
That's where high-intensity interval training, HIIT, comes in. They suggest specific circuits designed for that.
Like what kind of work rest?
Thinking really demanding. Maybe 20 to 30 seconds of all-out, multi-directional shuttle drills mimicking those set of CCs.
Max effort.
Max effort. followed by a very short rest, only 10 or 15 seconds.
Wow, barely time to breathe.
Exactly. And you repeat that for maybe 10 or 15 rounds. The idea is to build that ability to sustain high-intensity mobility even when fatigued, like you'd need a 20 all in the third set.
Building that clutch physical capacity makes sense. And what about using the tech itself in training, the IMUs?
Absolutely crucial, they argue. Since player load was such a key metric, coaches should use IMUs to monitor it during training sessions.
To make sure they're hitting the right intensity?
Yeah, and managing fatigue. They suggest aiming for session player load targets around 70 to 80, which aligns with the average match demands found in the study.
So you're training the body to handle competitive stress without overdoing it.
Exactly. It's about optimizing training load, preventing injury, and ensuring players peak at the right time.
Okay, this deep dive really paints a picture of elite men's singles badminton as, well, a game of calculated physical effort.
It really does. Success overall seems linked to efficiency, doing less work where possible.
But, and it's a big but, when you're up against someone just as good, victory demands that temporary strategic increase in explosive movement and high-intensity work.
That ability to flip the switch seems vital.
So maybe the final thought for you listening is this. In high-level sports, maybe the key isn't just what winners do consistently well, but when they choose to unleash their absolute peak physical output, it's not about constant maximum effort that's unsustainable.
Right. It's about that perfectly timed, strategic burst of energy when the moment demands it most.
Exactly. Well worth thinking about. If you want to get into the nitty-gritty of the stats, the methodology, how they defined everything, definitely track down the full article by Guo, Jiang, and their colleagues.
Highly recommended read for anyone serious about badminton science.
For sure. And to catch our next deep dive into sports science or other fascinating topics, make sure you follow the channel and maybe turn on those notifications so you don't miss out.
We'll see you next time.